So say we have an acid or a base that we do not know the molarity of. The way we find out what the molarity of the acid or the base is through a process called titration. And what titration is mixing an acid with a base until they are neutralized. And here we see that demonstrated up here on the board. We have an acid plus a base, which will yield a salt and water. And in this instance, our acid is going to be hydrochloric acid. That's the one that we do not know the molarity of. And our base is NaOH. And that one we do know the molarity of in this instance. And that will produce NaCl, sodium chloride, and water. Now, the way we find the molarity of the acid is by using this equation here. Molarity of acid times volume of acid is equal to molarity of base times volume of base. Now we know a couple of these things already. For one, we need to find out molarity of acid, which is multiplied by the volume of acid. In this case, we're going to use about 10 milliliters, which is 0.001 liters, which is equal to molarity of base, which we have already determined by making the base ourselves. And we have 100 milliliters here of 0.5 molar NaOH. So we can plug in 0.5 for molarity of base, and then we still need to find out volume of base. The way we find out volume of base is by mixing the acid and base together. And the acid will have a indicator in it, phenolphthalein, which will turn pink as the base begins to neutralize it. Now once the acid turns pink and remains pink for a good amount of time, then we know that we have reached the point where the acid is neutralized. Then we take the reading of the amount of base that we've used, which will be our volume of base in this equation, and then we can plug that in and solve for molarity of the acid. Today we are going to be doing a titration, and for the titration you either need to know the molarity of an acid or a base. In this case, we are going to know the acid of a base. And the way we're going to do that is by using this equation here. Molarity equals number of moles over liters, over volume. And the base that we're going to be using is going to be sodium hydroxide. And we're going to make the base by this equation here. Sodium hydroxide solid, which is going to be in pellet form, plus H2O, water, is going to equal aqueous sodium hydroxide plus water. Now the way we get the exact amount, or the exact molarity of sodium hydroxide, is by plugging it into this equation here. And we determined that we want about 0.5 molar NaOH. We plug that in here, and we want about 100 milliliters of it, which is 0.1 liter sodium hydroxide. Now we want to solve for molar mass, which is X here, and to do that we take 0.5 and multiply it by 0.1 liters, and that will give us 0.05 moles NaOH. Now we have to convert moles to grams by using this equation here. Moles equals mass over molar mass. Now we know the number of moles that we need is 0.05 moles, and that will equal mass, which will be our X value, over molar mass, which we know to be 40.0 grams NaOH. Now to solve for mass, we take 0.05 and multiply it by 40, which is equal to 2 grams NaOH. So right now we're going to make our 0.5 molar solution of sodium hydroxide in this. So what we're going to need for this is a 100 milliliter volumetric flask. We have a 250 milliliter beaker here that is filled with distilled water at the moment. Here's the distilled water. We have our sodium hydroxide pellets in there that we measured with our triple beam balance. We're going to be using 2 grams of the sodium hydroxide as we got from our equation. And I'm going to go ahead and add that into our distilled water.
How we're going to do that is we need 100 milliliters of it. So after doing the math...
The reason why we have the distilled water in the container at the moment is so that the reaction happens slowly and not all at once. And then after we add these pellets, we will add more water to it.
To count the mass of the cup holding the pellets.
These guys are just sticking a little bit here.
So we're going to measure for 20 grams total, 18.4 grams being the pellets and 2.5 being the cup. So we're just about there. Yeah. This guy's just going to do it.
Okay, so now that we have those in there, I'm going to go ahead and add more water until it reaches the 100 milliliter mark on the flask.
We get 100 milliliters of our base for the titration.
It's not even in our group.
Thank you much.
I already did it.
Yeah. I think we should use Davis's first one, but just edit and have some ones don't react.
Okay, and now we have our pellets sitting at the bottom there, so we just swirl this around until they dissolve, and we should have our 0.5 molar NaOH.
Okay, for this experiment you'll need 2 burettes. One will be full of a base, one will be full of an acid. The acid we will be using is HCl, which we do not know the molarity of, and NaOH, which we already explained is 0.5 for the molarity.
Everything over here is...
You'll fill up the burettes with the funnel to make sure you don't make a mess, up to the 0 mark. The acid you will drain into a 200 milliliter beaker, down to the 10 mark, so you know have exactly 10 milliliters in
Trial one.
Into the acid you will put 3 drops of phenolphthalein, so you'll know when it actually neutralizes. And for the base, you will just slowly drip it in, and drip it in until it hits the correct pink.
Let's say...
So now we're going to actually go ahead and do the procedure now. My partner here is going to begin adding 10 milliliters of acid into the beaker.
15.4. Okay.
We want to make sure that, be very careful that we only add 10, and we want to make sure that we write down exactly how much we add in.
I'll stir you guys in. You really should it in a little faster.
So now that he's added in the acid, what he's going to do is he's going to add in 3 drops of our indicator phenolphthalein in the little bottle there. And what that'll do is it'll change the color of the acid once we've added the proper amount of base to neutralize it. And after he's added that, we'll go ahead and move the beaker over to the acid underneath, or over to the base underneath, excuse me, and we'll slowly add in base until the color begins to change, and he'll swirl the beaker as he does that to mix it properly. And what we're going to see here is that the acid should start to turn a light purple and then become darker as you add base, but you don't want it to become too dark, otherwise you've gone too far. And what will happen is that pink color will fade as he swirls, but eventually that pink color will start to hang around and it'll get deeper. Now, once that starts to happen, then we add 1 drop of base at a time until we get the color just right. And this process can take a little while. You want to be careful that you don't add too much base. That way we get an accurate reading at the end.
There's like a drop right there.
Oh wow.
Okay, so the color started to hang around. It looks like we got about the color that we needed right at the start there. So what we're going to do now is just stop adding the base and take our reading off of the burette. And it's looking to be about 14.7 milliliters of the base.
I'll put some more.
We should put some more base in.
And what we do with that number is we take it back to our equation, molarity molarity of acid times volume of acid equals molarity of base times the volume of base, and we can then solve for the molarity of acid. Okay, so now we've done our 4 trials for our titration, and we've come up with our 4 different values for our volume of base, and our 4 different values for our volume of acid. And what we are going to do now is we're going to find the average of these. So for the average volume of acid, NaOH, we got 14.1575, which is 14.2 characteristic fixed. And then for our average volume of our acid, HCl, we got 10.5. Now what we do is we plug those numbers into our equation. Molarity of acid times volume of acid is equal to molarity of base times volume of base. We get molarity of acid times 10.5 is equal to 0.5 times 14.2. And when we solve for Ma, we get 0.676 for our molarity of acid.